What if you took code written by one AI coding assistant and asked a competing AI to review it? Not a human. Another AI. Would it catch the bugs? Would it flag the security issues? Or would it wave the code through because both models were trained to think the same way? We ran that experiment, and what the AI coding assistants miss tells you a lot about how much you should trust them. Before we get into the results, here is how the test worked. We selected 4 widely used AI coding assistants and had each one generate solutions to the same set of coding tasks. These were practical tasks, not trick questions. Things like writing a REST API endpoint, handling user authentication, parsing file input, and managing concurrent requests. Then we fed each tool's output to the other tools for code review. Each reviewing tool was given the same prompt. Review this code for bugs, security issues, and edge cases. Flag anything that needs attention. We logged every comment, every warning, and every piece of code that was passed with no notes at all. That last category turned out to be the most interesting. The first thing we noticed in round 1 is that AI coding assistants are generally good at catching obvious formatting issues and simple logical errors. If a variable is used before it is declared, or a loop condition is clearly wrong, most tools flag it. That part of the review works. The problems start when the code looks right but behaves incorrectly under specific conditions. Off-by-one errors were missed consistently across the board. This is a classic programming bug where a loop runs one iteration too many or too few. When AI tools generate code, they tend to produce off-by-one errors in array indexing and range calculations. When other AI tools reviewed that code, they missed those same errors at a high rate. All 4 tools showed this pattern. Missing input validation was the second major blind spot. One tool generated an API endpoint that accepted user-submitted data and passed it directly into a database query with only minimal sanitization. 2 of the 3 reviewing tools gave that code a clean pass. The third tool mentioned that validation could be improved but did not flag it as a security risk. In a real production environment, that code would be a serious vulnerability. Race conditions were almost universally ignored. When one tool wrote an asynchronous function that modified a shared resource without proper locking, none of the reviewing tools flagged the potential for concurrent access issues. This is a bug that only appears under load, and it can cause data corruption or application crashes. Every single reviewing tool missed it. So why do AI coding assistants keep missing the same things? The answer has to do with how these models learn what good code looks like. They are trained on enormous amounts of code from public repositories. Most of that code works most of the time, which means subtle bugs that only appear in edge cases are underrepresented in the training signal. The models learn to recognize code that looks like working code, not code that is provably correct. There is also a reinforcement learning factor. These tools are fine-tuned using human feedback, which means a human reviewer approved many of the examples the model learned from. Human reviewers miss race conditions and off-by-one errors too. The model has essentially learned to replicate the same blind spots that exist in human review, at scale. The security findings deserve their own focus. Across the full test, we found 3 categories of security issues that no AI tool flagged consistently. The first was insecure direct object references, where code exposed internal identifiers in API responses without authorization checks. The second was improper error handling that leaked stack traces to the client. The third was hard-coded fallback credentials left in configuration functions. Hard-coded credentials are worth pausing on. One tool generated a configuration function with a comment that said something like, "Replace this with your real password before deploying." A second tool reviewed that code and did not flag it as a security concern at all. It noted the comment but treated it as a developer reminder rather than a risk. In a codebase where that function gets committed to version control, that comment becomes an active security problem. There was one area where cross-review actually worked well, and it is worth acknowledging. When it came to code style, naming conventions, and documentation gaps, AI tools reviewing each other's code were genuinely helpful. They caught inconsistent naming, missing docstrings, and functions that were too long to be readable. If your only goal is cleaner, more consistent code, AI cross-review adds real value. But style is not safety. A well-formatted function that silently corrupts data under concurrent load is still a production incident waiting to happen. The tools are optimizing for the wrong signal when it comes to correctness, and that gap becomes significant the more you rely on them. What does this mean for developers and engineering teams using AI coding assistants right now? The first implication is that AI cross-review cannot replace human review for security-sensitive code paths. It can supplement a human reviewer, but it should not substitute for one. The categories of bugs that AI tools miss are exactly the categories that create real production failures. The second implication is that static analysis tools and dedicated security scanners still have a role that AI has not replaced. Tools like linters, type checkers, and automated security scanners look for specific patterns using rules that were written explicitly. They do not generalize the way language models do, and that specificity is actually an advantage when you are hunting for known vulnerability classes. The third implication is that your review workflow needs to account for shared failure modes. If the same AI tool that wrote the code is also reviewing it, or if the reviewing tool was trained on similar data with similar weaknesses, you are not adding a second opinion. You are running the same check twice. Diversity in your review process is not just about having humans in the loop. It is about making sure the checks you use do not all fail in the same way. A practical workflow that addresses this looks like the following. Use AI coding assistants for generation and first-pass review, because they are fast and they catch real mistakes. Run static analysis and security scanners as a separate automated step in your CI pipeline. Reserve human review for any code that touches authentication, data storage, external APIs, or shared state. That layered approach gives you the speed benefit of AI tools without trusting them beyond what the evidence supports. One thing this experiment changed for us is how we think about confidence scores. When an AI coding assistant says something like "this code looks good" or "no issues found," that statement carries implicit confidence. But based on what we saw, that confidence is not calibrated to the actual risk of the code. A clean pass from an AI reviewer is evidence that the code passes the checks the model knows how to run, not that the code is correct. The tools tested here are genuinely useful. That is the honest answer. They reduce time spent on boilerplate, they catch obvious mistakes, and they make it easier for developers to move faster on routine work. The problem is not that the tools are bad. The problem is the assumption that because a tool is powered by a large language model, it must also be good at the nuanced judgment calls that matter most. The field is also moving fast. Some of these limitations are being addressed in newer model versions and with tool use features that let AI assistants call external analyzers. It is worth staying current on what each tool can actually do today rather than assuming the version you used 6 months ago represents current capability. To recap what we covered, AI coding assistants consistently miss off-by-one errors, input validation gaps, race conditions, and several classes of security vulnerability when reviewing each other's code. The root cause is shared training patterns and reinforcement feedback that mirrors human blind spots. The practical response is a layered review workflow that does not rely on any single type of check. If this gave you a clearer picture of how to use AI coding assistants more carefully, hit the like button. It helps more developers find this kind of practical breakdown. Subscribe if you want to keep up with honest, evidence-based coverage of AI tools for developers. Next up, we are testing whether AI coding assistants can actually debug production errors or whether they just generate confident-sounding wrong answers. That one is worth sticking around for.